We now analyze the performance of the random code that we have constructed. Recall that in the code construction, we fixed the input distribution fx such that the expectation of kappa of x is less than or equal to p minus gamma, and the mutual information between x and y is greater than or equal to c of p minus gamma minus epsilon over 6. Let the components of the code word x tilde of w be x tilde 1 of w, x tilde 2 of w, all the way to x tilde n of w. Define the error events ERR as the union of two events E sub E and E sub D, where E sub E is the event that the random code word sends through the channel violates the input constraint, and E sub D is the event that the decoding is incorrect. By symmetry of the code construction, the probability of the error event is equal to the probability of the error event conditioning on the first code word being sent. By the union bound, this is less than or equal to the probability of E sub E conditioning on w equals 1 plus the probability of E sub D conditioning on w equals 1. The analysis of the second conditional probability above is exactly the same as the analysis of the decoding error in the discrete case. So we can choose delta to be small to make this probability less than or equal to epsilon over 4 when n is sufficiently large. We are now going to apply the weak law of large numbers to analyze the probability of the event E sub E conditioning on w equals 1. This is the probability that the first code word in the codebook violates the input constraint, conditioning on w equals 1. Since the choice of the message is independent of the code construction, we can remove the conditioning on w equals 1. In the next step, we subtract gamma and then add gamma to p. Then we replace p minus gamma by the expectation of kappa of x to obtain an upper bound. This is justified because the expectation of kappa of x is less than or equal to p minus gamma, and so the upper bound is in fact the probability of a potentially larger set. Now x tilde I of 1, that is the ith component of the first code word, has the same distribution as x. And kappa of x tilde I of 1 has the same distribution as kappa of x. Now 1 over n times summation I equals 1 up to n, kappa of x tilde I of 1 is the average cost for transmitting a symbol in the first code word. When the block length n is large, by the weak law of large numbers, with very high probability, it is very close to the expectation of kappa of x. Then the probability that it exceeds the expectation of kappa of x plus gamma would be less than or equal to epsilon over 4 when the block length n is large. Therefore, from here, here, and here, we obtain that the probability of the error event is less than or equal to epsilon over 2. Which implies that for some codebook C star, the probability of the error event is less than or equal to epsilon over 2. Now rank the code words in C star in ascending order according to the probability of the error event conditioning on C star and the message chosen being W. After discarding the worst half of the code words in C star, if a code word x tilde W remains in C star, then the probability of the error event conditioning on C star and W equals small w is less than or equal to epsilon. However, it is not clear whether the code word x tilde w satisfies both lambda w less than or equal to epsilon and the input constraint. Since the error event is equal to the union of the event E sub E and E sub D, and the conditional probability of the error event is less than or equal to epsilon, we have the conditional probability of the event E sub D less than or equal to epsilon, where this conditional probability is in fact lambda w. And also, the conditional probability of the event E sub E is less than or equal to epsilon. Now observe that conditioning on C star and W equals small w, the code word x tilde of W is deterministic. So the conditional probability of the event E of E is either equal to 0 or equal to 1. That is, either the input constraint is violated or it is not. Now, since the conditional probability of the event E sub E, that is, the input constraint is violated, is less than or equal to epsilon, we conclude that this conditional probability is equal to 0. That is, the code word x tilde of W does not violate the input constraint. This completes the proof of the achievability part of the channel coding theorem.